Hello everyone. In this video, we will discuss logic gates and their truth tables. We will cover the inverter, AND, OR, NAND, and NOR gates. Truth table represents the combination of 0 and 1 of the inputs versus the outputs of the logic gate. We will practice drawing the diagram of each gate, write the Boolean expression, and fill in the truth table. So let's start with the inverter. Drawing the inverter is like this. I will have one input coming in, and at the end, I represent this as the output. I need to assign the input letter for this gate, so start with the capital letter A. Coming out from here, represented by a bar on top of the A. So, in this case, A bar is the Boolean expression of this inverter. And for the truth tables, I should have A and A inverted. So let's talk about the combination of 0 and 1. So in here, I will have one input, but I will have either 0 or 1. Okay, so you write 2 to the exponent 1, and calculate this, I should have 2. This number 2 will tell me that I have 2 combination of 0 and 1. Alright, okay. So to write the two combinations of 0 and 1 is always started with a 0. So right here you put 0 or 1. The output of 0 and 1 would be 0 will turn into a 1 will turn into a 0. Okay, so let's visualize this inverter in terms of the switch. So if we have a switch, if I open the switch, this is represented as 0. If I close the switch, this is represented as 1. If I'm talking about voltage, okay, measure in volts, then if I have 0, it's represented as low. If I have a 1, it's represented as high. Alright, okay. So let's continue on with the AND gate. Okay, I will draw the AND gate with two inputs. Okay, so two inputs. We will denote it as capital A, capital B. Coming out of this gate, I will have the Boolean expression for the AND gate as A dot B. Or you can write it as just AB. Okay. So again, let's go over the combination of 0 and 1. So in this case, I have two inputs. I have two possibilities of 0 or 1. So I should have 2 to the exponent 2, give me 4. So this number 4 tells me that I should have 4 combination of 0 and 1. Okay, so the truth table will start with A, then B as their input. So the last column, I need to write the output, which is A dot B or AB. So to write the combination of 0 and 1, you should start with 0. So in this case, I should have 0, 0, 1, 1, 0, 1, 0, 1. For the AND gate, I would like everyone to visualize that. I have two switches, but I actually connect them in series. Alright, I connect these two switches in series. Okay, so if I close just only one, the signal won't go through. So in this case, what I have is 0 and 0 will give me A0. 0 and 1 also give me A0. 1 and 0 will also give me A0. The only time that I have a 1 is when both of my inputs are 1. So in that case, I need to close the two switches in order to have the output of 1. Alright? Okay. So let's move on to the AND gate, but this time I will draw it with 3 inputs. Okay, so 3 inputs. And I will put A, B, C. The Boolean expression for this AND gate with 3 inputs should be A dot B dot C, or you can write that with just A, B, C. Again, we will analyze the combinations of the 0 and 1. So you have 3 inputs. You have 2 possibilities of 0 and 1. Therefore, you are going to write 2 to the exponent 3, which is equal to 8. This number 8 tells me that I will have 8 combinations of 0 and 1. Alright, we will write A, B, C. The Boolean expression is A dot B dot C, or A, B, C. And we must have 8 combinations of 0 and 1. And to be consistent, I would like everyone to start with 0. Alright, so to start with 0, the first column, you should have 4 zeros, then 4 ones. The second column for B, you should have 2 zeros, then 2 ones, 2 zeros, and 2 1. The last column, you will alternate the 0 and the 1. So 0, 1, 0, 1, 0, 1, 0, 1. So for this AND gate with 3 inputs, the only time I have 1 is when I have all 3 signals equals to 1. So the last row I will have the 1, but the rest of them is all 0. Alright, let's move on to the next gate, which is the NAND gate. The NAND gate is the combination of the AND gate and the inverter. Okay, so let's start with the NAND gate with just 2 inputs. So I will draw the NAND gate with 2 inputs, A, B. So coming out of this, I will insert here an inverter. That means right here I should have AB, but I invert the signal coming out of it. Or you can write it as dot B. Coming out of here, you have A dot B inverted. Okay, so here's my A, B, Boolean expression as B, A, B inverted. And similar to the above truth table that we developed here, I will put 0, 0, 1, 1, 0, 1, 0, 1. Coming out of this, I should have 0, 0, 0, 1. And I invert my signal, so my last column should be 1, 1, 1, 0. Alright, so let's write our NAND gate, but with 3 inputs. Okay, so I will draw my NAND gate with an AND gate with 3 inputs, and I will insert the inverter at the end. So A, B, C. Coming out from here, I should have A, B, C, but then I invert the signal. You can write it as A dot B dot C, similar to A dot B dot C and all inverted. Alright, okay, so let's draw it here. That signal is coming out from there. And there's another way of drawing this inverter by just put a circle at the front. Alright, so in this case I will have ABC inverted. The same thing for the two inputs here. I should, instead of drawing an inverter, I should put the circle at the front. So coming out of here, I just have AB inverted. Okay, again, similar to this truth table, I will be consistent by assigning the first column for A as 4 zeros to start with, and then the last 4 is the ones, and this is the B, 2 0, 2 1, 2 zeros, 2 1. C will be alternation of 0 and 1. Okay, and coming out of this, I should have A, B, C. That means everything is 0 except for the last row. And A, B, C inverted. That means I invert all of this signal. Alright, okay. A reminder to everyone. If you write your combination of 0 and 1 in this pattern, you will not miss any combination of 0 and 1. Because don't forget, 2 to the exponent 3 will give me 8, and I must have 8 combinations of 0 and 1. Alright. Okay, let's move on to our OR gate. Okay, so OR gate with 2 inputs, I will draw it like this. Okay, so we draw this as a curve here. So I will have 2 inputs coming in, A, B. Coming out of the end, I will have A plus B as Boolean expression for this gate. Okay, so I would like everyone to visualize this as if I put the 2 switches together. What I actually do is I connect them in parallel. Alright, so if I close any of the switch, then I still have the signal coming through. Okay, so let's put the 0 and 1 into this truth table. Okay, so again, for A will be 0 0 1 1. For B will be 0 1 0 1. A plus B, it means that as soon as I have a 1, my signal will be 1. Okay, so the first row will be 0. I see a 1, so there's a 1. I see a 1, so there's a 1 and a 1. Right. Okay, so let's draw this OR gate with the 3 inputs. So 3 inputs. I will have A, B, C. Coming out here, I will have A plus B plus C. Okay, again, I would like everyone to visualize that I put these 3 switches in, I connect them in parallel. So if I close any of the switch, I still have the signal going through. Okay, so again, A, B, C, and A plus B plus C, or they say that A or B or C. Okay, again, repeat the same pattern. The first 4 0 for A, the last 4 1 for A. So 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. And again, I emphasize to everyone that we should be consistent And in this class, we will always start our truth table with this pattern. Alright, the first 4 0 for A, the last 4 1s for A, and then B will start with the 2 0, 2 1, 2 0, 2 1, and the alternate of 0 and 1 for the C. And we always start our truth table with the 0. So in this case, what I have is I will have 0 for the first row because all 3 of these inputs, all 3 of these switches are open. Alright, so as soon as I close one, I have the signal going through, so therefore I will have 1 for the rest of them. Alright, okay, so let's move on to our NOR gate. Okay, for the NOR gate, basically that I have an OR gate and I put the inverter at the end. So for 2 inputs, I should draw it like this. I have 2 inputs coming in, AB, to this OR gate. At the end, I put an inverter here. So you can write A plus B right there, but that I invert the signal. So I put a bar on top of A plus B. Alright, so the truth table will be A, B, A plus B. Then I invert the signal coming out of it. Again, same pattern for the 0 and the 1. So I will have 0, the rest of them will be 1, but I invert my signal, so I have 1, 0, 0, 0. Okay, another way to draw this NOR gate is to put a circle here instead of putting the inverter. Okay, so I can draw it like this. Make sure we label all our inputs, and we should always start with an A. Alright, so with the 3 inputs, again, similar to this, I will have 3 inputs coming in as A, B, C, and I invert the signal coming out of it. I can also draw my NOR gate as this. Okay, again, I emphasize that we will start with the 4 zeros and 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, and I should have A plus B plus C, and I have A plus B plus C inverted. And in here I should have the first row will be a 0, but the rest of them will be 1. And I invert my signal, therefore I should have 1, and the rest of them will be 0. Alright, thank you.